So 20 So our simplest definition of balanced forces, right, just involves two forces. So our forces which have the same size but act in the opposite direction. This means they cancel out and have the same effect as no forces acting. Now that's the definition based on two forces in more general terms. So in general, so if you had more than two forces, you could still have the idea of them cancelling out. And so the more general definition for balanced forces is that the resultant force is zero. Okay, and then learning outcome 23 is Newton's first law. And basically it tells us what happens when there's balanced forces or zero forces. So it expresses it with a kind of that almost like a double negative, unless there's an unbalanced force. So an object, and there's two possible ideas that you saw with the Atwood's machines. If something's at rest, then it remains at rest. Or if it's already moving, it'll move with a steady speed. In a straight line. And like we say, we could actually combine that into one statement, a steady velocity. That would include the idea of same speed in a straight line. And that will happen unless there's an unbalanced force to cause a change. Now just don't be confused as well if you see it expressed in terms like a body will remain at rest. Remember, body is just a word we use in physics to mean object. It doesn't necessarily mean a human body. Probably worthwhile giving a couple of examples there. So e.g. in actual fact what I'll do is I'll draw. So a book on a table. We've got a book sitting on the table. Weight, remember, not gravity. Weight pulls it down, and that's balanced by the table pushes it up. So for a parachutist, and clarifying that the parachute is open, watch out for my fantastic art skills here. Okay, so we've got our parachutist falling. What forces would be acting? Any ideas? Yep, so weight would be pulling them down. So we draw these force diagrams with arrows to represent the forces. Right. Right, so weight pulls him or her down. Is that the only force acting? What's the point of a parachute? Yeah, or drag in general, okay? Air resistance, lots of names you could call it, right? But drag from parachute and because friction always opposes motion, remember? Right, drag from the parachute acts up the way. Actually, I'm going to change that from up the way to upwards. Sounds better. And then, sorry, I should have put this in. A parachute is falling at a constant speed. And once again, I'm assuming there's no wind that's going to change their direction or anything like that. So that's the only two forces that we're interested in. And they're balanced forces.